Good morning. Hello. Happy Thursday. We are back to exploring Git. Exploring, maybe not the right word. We are back to creating our own Git. That's what it is. And we're on the trees. And I was thinking about something this morning, last night, one of those two. And I was wondering if maybe the command that we were working on is okay in the end, maybe, but they're going to be handing us just a file with text and just folders in it, nothing really else, and like no binary stuff in there. I'm wondering if that's it, because getting the names of it when we're implementing ourselves, I'm not sure how that exactly works. We could also look at the example code from other submitters too, and sort of like see how that's working. But let's jump back into it. So this is what they're thinking of, is we're gonna have a repo, we're gonna have files, directories, and then files in the directories. And then what we want is the top level stuff, right? So dir1, dir2, file1. Now, what I'm curious about is, are they gonna be putting these files as just they're going to put binary files in here or not, if for theirs? I'm kind of curious. Oh, they have test cases too that we can take a look at. They're the actual tests, which are written in Go. Okay, writing a tree to get storage. So they create a root.txt. Interesting. Okay, so what goes in those files inside of there? So we have root file, which is just that, root.txt. And then we have root dir1. Do we see that being created? Oh. And we have our second level, random. Okay, so random string, random. Okay, do file. Okay, then interesting. Okay, so I don't know what these. So root file. Okay, so these are variable declarations, right? So we're root file, root directory, root directory. So are these destructuring out essentially? That's sort of what it looks like. I don't know if that means like it's actually becoming, yeah, it feels like this is a destructuring operation. And then we have our second level. So that's inside of root dir1 file1. Okay, throw those in there. And then it writes all down. Okay, so, and then it probably adds it, does the command to add it in, and then we want to read it out. So the question in our ls tree, okay, we get the content byte. So right now we're getting the header from it, and then we have the rest of the content. So the rest of the tree essentially is going to be equal to our bytes of index to the end. I think right now this has a, I wonder if we can read this as like a file. Let's see, am I doing this as read? We have decompress. What were we doing in a cat file? Okay, so we have read to end in the buffer. We decode it. We're just reading to string, but I don't think we're allowed to read to string with this one, because I don't think regardless of what's in here. So let's see, we have our tree here. So then what do we want to do with this afterwards? If I tried to read this to a string, I think it crashes, but maybe it doesn't crash if I do it with my own tree structure, like what they're doing. So if I have like my content, that just places them into a buffer, but I already have that essentially. So I don't know how helpful that is. I could print it out maybe. So if I read a string, this crashes when I do it on my thing. You need to be mutable too. And then we're gonna print line. Oh, this is like trying to print. Okay, this is trying to print from UTF-8 header. Oh, okay, so I can actually do that on tree here. So hold on, let's try that. So if I try to just print whatever we have out, maybe that will help. And then we're ignoring header essentially. We don't need that. That's fine. Now, if I do this on one of our, oh, I opened this twice. That's not what I wanted to do. I can hear Zilby snoring a little bit, which is really cute. Okay, let's have full screen that. That's what I had. I had this opened already, and I need to reload you so I don't have any weirdness. And okay, let's do a cargo run. Okay, so I wanted to do this one, but I think this panics, right? This panics because it doesn't know how to turn it from it's not UTF-8. It's not UTF-8 in here. I wonder if I just create this ourselves. So if we just create a touch test. Do I already have that test file still? I still have this test file here. I wonder if I create a new tree as the root tree for this. So we have test. Can I also do, let's take tester, then we'll touch test file.txt, take another dir, touch more test file.txt. Okay, so if I just do that, I want to hash this one. So what is it? Get, not hash object, it would be hash tree, right? Is that a thing? Hash tree is not a command. Get the plumbing. So we have hash object. I wonder if, no, write tree. That's probably what it is. Create a tree object from the current index. Okay, so that must be what it is. So get write tree. That, okay, that gives me this. Now if I cargo run, which I have to do it from the base directory, and I hand it you, that still panics. Okay, so I have to figure out how to get the names out of here from the hash. Okay, so yeah, this part has me a little bit confused. Now they have this Stack Overflow question, which we can look into, which was it for a tree object? Okay. Yeah, the get ls tree, which then that gets us the thing. So we want to look at what they're doing. So the format of the tree object. So we have tree content size, entries having references to other trees and blobs. So it would be something like this, right? The number 1 as the first character of a mode shows that it's, oh, so we get this. So that's a reference to a blob file. The example above, pom.xml, is a blob and the others are trees. So the rest of these are trees because they're 4s. Note that I added new lines and spaces. Okay, yeah. Then you have this thing. Oh, okay. So we go through this thing each time. Okay, so basically we get then this thing. So more exploration sort of like into what this is. So we have the header, so we can get this part. So we get the header. Now I need essentially this, which it looks like that's not always the same size, but we can check the first. Basically, we just want to go again until we find another null. So where do we have that? Here's, okay, so index bytes. I wonder if I want to just put this into a, throw this into a utility function just to find the next index. So index of the next null, maybe. Let's do that. Let's go into our utils. Oh, right, we're writing an actual test for these. Okay, so if we take in our bytes, I want to return a usize, probably an option usize because it might not exist. Let's return a none, and then we'll test this. Okay, so this is should return index of next null. All right, so we have our, let's say we have a string. So it basically comes in as U8, doesn't it? Okay, so we can figure this out. So we have our string. It's going to be just something like that, but we have a 0 in here. We could have even 2. Okay, so we get our string from that, and then, okay, so should return index of next null. And then I want to hand it the bytes, and then we're going to get the index of this should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I think. We'll get our result. Now, I want this to be an unwrap, because if that fails, then I want that to hard crash. We're going to assert equal. We have our result and our expected index. Okay, let's test this. Failed. Okay. Oh, right, because I'm always returning none. Yeah, that would do it. All right, so let's make this not always return none. We want to loop through this until we find the first none, which I believe has, let's see. I think we could just do this straight off of bytes, right? So we can do bytes. Do we have to get an iter, or is it just available to us? It's something like, it's not contained. I forget the name of it. It's in the other file. We can just go take a look at it. I think it, was it starting to look at the M or a P? Nope. Okay. I think it's bytes. We get an iter, and then I think maybe this one will work. Oh, position. That's what it is. Okay, so it's position. I want to get, we get a predicate. So this is going to be a byte, and I want to check that our byte is equal to a null, and that's it. Return that. Oh, can't compare a UA. Oh yeah. So we just want to that. Expected a U8. Oh, this needs to be as a U8. Bytes. Is it not bytes? Is it just bytes into bytes? Can I destructure that? Mismatch types found. Expected. Oh, just a U8. Okay, that's the problem. I want the first one. That should work. Oh, right, I could do that too. Forgot. I can do that just to get the single literal. Let's do that. That's a lot better. Did I do that last time in the other file? I did do exactly that. I forgot. Okay, so it's basically B0. Yeah, there we go. And we return you. Okay, so let's check our tests now. Okay, everything's passing. So now I can use the index of the next null and hand it something. It will tell me the index of the next null if it exists. So this is first null index. So this is really header, right? This is like the header null. The header null index is index of next null, and then we hand it the byte. So what are those? That's the content bytes. We're pretty sure that you should exist, but if you don't, that's a problem. So let's expect. Don't have a header. That's obviously a problem. Okay, so let's not worry about you right now. Let's throw in the header null index. Okay, so this is going to be our content bytes. Oh, we actually have this right here. Header null index. So give me this from the header. Okay, so this should print out what the header is again, which we had previously. But now we have our own tree to do this with. You failed. I did save, right? Okay. You failed. UTF-8 error, valid up to 34. It is at line 28. Okay, so it's at this line. We're trying to turn it into a string from a UTF-8 for header. I'm trying to go from 0 to the null header to the header null index. Okay, so I'm trying to get the header out of it. What is that? Debug our header null index. What are you? Header null index is 316. 316 seems wrong. Content bytes, maybe. Okay, so yeah, we have bytes. Okay, you're right. That's exactly right. Okay, wrong one. Let's try that. There we go. Okay, so now we have 8 is more appropriate, and here's our tree 338. So thank you for that, Japfolk. Okay, next up, we have our header null index. Now I want to get whatever that next chunk that we see here is. Like whatever this is, which is So tree content size, and then entries having references to other trees and blobs. And then, okay, that's going to be a mode. Okay, so we're going to get a mode. So our mode index. So index of next null, and we're going to pass it the bytes, but we need to make sure we start at the header null index and go to the rest of it. And again, let's expect this and just say doesn't have a mode. Okay, so let our mode is now going to be equal to our bytes of header null index through the mode null index. And let's now print out the mode. Content bytes versus bytes issue. Maybe naming is a bit misleading. Let's see. So is it like these are still bytes, right? But oh yeah, this thing is like you do have, okay, so we have the content bytes. Yeah, these are, maybe we should name this compressed bytes. That would probably be better. Okay, so our compressed bytes, and then we have the bytes. Okay, you are going, okay, so now we see, oh, it panicked. Slice index starts at 8 but ends at 0. So I'm trying to go from 8 to the end, but bytes, interesting. What's the length of bytes now? 347, okay. What's the length of bytes if I do this? 339? Wait, did it get bigger? No, it got smaller. Okay, it's got smaller by 8, which makes sense. Okay. And then it won't be that bad. Okay, so it's header null index. Okay, so you have the length. I do pass it in the bytes after we get the decompressed bytes. I want to get the next one. We don't get, this doesn't have a mode here, do we? The error is slice index starts at 8 but ends at 0. I kind of want to go back to my test and do this like twice, right? To say like, okay, should of second null. So if we have just more data in that, okay, so expected index, so that was like what? That's a 16, so 17, 18, 19, 20, 21, 22, 23, 6, 3, 37. So I get the first one, right? So, and then I want to take, oh, I do need the first index here. So of first index, the end. What are you upset about? Expected, okay, so you want that. And then you'll be expected index. Nope, you're the, what did I do here? This is result. Okay. I would expect that this fails, right? To match what we're getting. And it does. Okay. Should return index of second null, and it gives me 0. That's not cool. This will report the offset, but not the index. Oh, yeah. That's true. That's true. You think it's 0 because how we sliced it with the 0 first. Oh. So maybe you have to slice it with +1. But you're right. You're right. This is not going to work the way we expect it to. So what I think we're going to need to do, index of the next null, because unless I want to start doing things like, okay, first index and get that out of there. Well, I guess what we could do, this kind of works. We can get like the slices of it, right? So we can just say we have our first index, and so this is not great, but it's fairly cheap memory wise. Like it's cheap memory wise, it's cheap everything else wise, and it should be abstract. It should be optimized away so it's not like hurting performance at all. So if I store our slice off as a second thing, then it's going to make more sense, right? So we have our full string here, and then I want let the like all bytes, like string bytes, so as bytes, and then we're going to use our string bytes here. The expected index. Okay, so then I want to I get the first index, and I want the next section, which is going to start from here. So I want section 2 is going to equal to our string bytes. So starting from +1 probably, right? So that's going to be expected index +1 through to the end. Our expected index is now going to be different, right? So starting here from 0, it's at 20. Okay, so then we have a result equals index to next null, and then we hand it section 2, and this is the first index that we then add 1 to. Then we get a result is that, and then we should get expected. Let's find out if that works. That does work. Okay, so we were off by 1. Off by 1 error. Yay! Pass the start index, have the slice happen inside the lookup. So initially start equals 0. That works too. I think that might be good. I kind of like that idea. So let's update this. We're gonna have to. Okay, this is gonna be one of those things where you have to change the code up here first, and then we'll change the test to handle it. So let's change the signature. We're gonna take the bytes and then an offset index, which is gonna be usize. Our offset index is gonna be 0, and you're gonna start with 0, and then so our first. Okay, so we get the string bytes. Our first index is that section 2. So let's say we don't get section 2 like that. We get our expected index. We're now back to, if I'm going off of the original thing, I think I want 37 again, don't I? Which then I wonder if I don't want that other kind of like loop, the position. Unless I can get like multiple positions. Result insert of index of next null. We hand it the string bytes, and then the offset is going to be the first index +1, and then I don't think we're gonna. I think this is not going to work out quite as nicely as we were hoping, because this isn't going to tell me. Oh wait, it might. I then skip offset index, and that might give me what we're looking for. Oh wait, I'm not gonna be able to even compile for the test, am I? No. Okay. So the header null index, that's gonna be an offset of 0. The mode null index is gonna be an offset. So this is gonna be interesting. So we just give it the bytes again, and then the offset is gonna be the header null index +1. Left is 20. Oh, it didn't get it. Okay. Yeah, we're gonna have to change. Okay, so we have to add the offset in. Okay, so we can do this. This is gonna be in our utils. I want to let our result. So this is gonna be the index, that, and then I want to return index plus the offset. Oh, and you need to be okay, so we're gonna return. I might as well just do this as an if let sum for that. Then this becomes okay, so I'm gonna have we return the index plus the offset. Oh, but you're gonna have to be sum. Otherwise, we return a none. Like that. Okay, that works. So then back to ls tree. Okay, so now we have the mode null index. We're not using that header right now, so I guess what we can do is we can here we have the header and we have the mode. Let's see if this works. Okay, there we go. Here is our okay, so we have our header and we have the first mode. That is a 1. Okay, so the number 1 as the first character of a mode shows that it's a reference to a blob or a file. The example above. Okay, but you only want the top level, don't you? So we just have this. Oh, that's cool. And then I can do this again. Then I can just continuously run this over and over and over again. So let's we're gonna need to loop through, aren't we? Because we're gonna have, it's not just, I guess it's the mode and then the file name, right? We have the mode and then a file name. So it's really, this is mode and file name together. Okay, so I want to split off the, okay, so we have, we don't really care about the header. We just sort of grab it out. I don't need you anymore. Okay, so we have the mode and file name. I just want to grab the file name, don't I? So if I take this UTF-8, I should be able to turn that into a string and then split based upon the space. And then we have the mode and then the file name, which kind of makes me feel like I want a struct here, which would be something like, I might want to put this into utils. So if I have like a struct of like the mode with file, what would this be, the hashed file? This is a tree. Okay, we could do this as like a tree object. Do I want this in utils? I don't know if I want this in utils. I'm gonna put this in here until I know better. So this is a tree object. We're gonna want a header. Now in each of these, I probably want to store them as not the bytes themselves, but as like the actual things. Like this would be the string. And looking at what we get out of here, so we have tree and size. So okay, this is kind of just an object, isn't it? Oh, and the object is going to be shared by multiple things, possibly. Object type. Let's just store these right now as just strings. Let's not worry about it. So we have string. We have the size. That's going to be a U something. It shouldn't be that large, but we'll go with the U32. Then we have the mode, which is going to be a number, right? It's always a number. It is. So let's go with like a U32 also for that. And then we have the file name, which that will be a string again. So I feel like this should probably be a just an object, and we probably want to store this in utils, or like maybe have it give it its own file. Like I feel like that's where we're going to end up going with it, especially when we go to write. But we'll get to that. We'll do that when we get there. Okay, so let's do a pub function new. So if I'm creating this, I want to hand it in the bytes that are decompressed, like the decompressed bytes. So we have the bytes, and that is another problem for future self. See, I am like, that future self person, like, I am really not happy with them. They need to they need to do more work. Look at all this. Me, current self, doing all the work myself. Do I see future self coming in here to help out? No, I do not. They know what they did. Absolutely. See, you got it. Just remember, always be mean to future self because current self is the best you. Okay, so if we get our bytes, okay, so we want to get the header together. So, oh, blah, redeemed pet the cat. Oh, I forgot to refund that one yesterday. So let's Sylvie, hi. Let's do some petting. All right, and then let me go and let's see. There, all done. Okay, so we get our header, right? So we get our header, and do I want to get like the index of this first? We actually have this, don't we? So we can get the header null index, and then this, and then that lets us get the header. Now from the header, I want to turn that into a string. So let the, so these are really header bytes, aren't they? And then the header, we get that into a string, and then I want to split that. So then, okay, then we're gonna have, how does split work again? I vaguely remember that we did it. So we have header, we want to split white space. Let's trim first, just in case there's white space on one side or the end. So trim and then split white space. That gives us a split white space. Okay, it's an iterator. Oh, okay, and then we should have the first and the second. So then we should be able to do something like let our object type is going to be equal to header dot next. Wait, can I not do next on this? Is that not? No method found for struct string. Wait, what? Oh, yeah, because I didn't like actually save it. That would probably be helpful. Okay, we can just shadow the header at this point because I don't really care about it, and just overwrite that. Okay, so we have splits. Then I want header dot next. There we go. That gives us, okay, an option string. I want so we can unwrap you and then to owned it. That should be fine. That gives us a string, and that's our first object type, right? So we have our object type. Now the second thing is going to be the size. So that our size is going to be equal to our header next, unwrap, and then that should be a number. Into, do I do an as? Oh, we do a parse. More unwraps because we love unwraps here. And then this becomes the size. Okay. This might be working. Okay, so then we get the mode. So the mode is, we get the mode index from here. So this is all to get those two. So let's do another line. Okay, so we get the mode null index off of the header null index +1. Okay. And then we get the mode and file name after there. We then get, okay, so I have to read this to a string too. So this is going to be the mode and file name. So we have our bytes. This will be a string new. Mode and file name, bytes, read to string, mode and file name. Okay, that gives us that. Now I can, we want to split you, and you should be two things. So I do the same exact thing where we say, okay, let our mode and file name, do you have to be, I can't remember if you need to be mutable. No, I don't think so, because an iterator is not mutable. Okay, so I want to read a string. Okay, so we're going to do mode and file name, we get an, we trim you, we split white space, and now I want to get the mode. So let the mode is going to be equal to the mode and file name next, unwrap, and you're a U32, so we're going to parse and unwrap again. It would literally be easier for me to throw in error handling, proper error handling. Like, there'd be less typing, which is kind of ironic, isn't it? Okay, so now we have our mode. And then finally we have our file name. It's gonna be equal to our mode and file name. Next, unwrap, two owns, no unwrap there. File name. You're pretty sure the mode is stored in octal representation? We are gonna find out, aren't we? I could swear though, when I did the read to string, this is what it showed up as. Which that might be octal. Yeah, maybe I do need, okay, so here, we're gonna do the exact same thing. And if it gets a different number here, then that's obviously, we need to fix that. All right, what are you upset about? Cannot mutate. Okay, so header bytes needs to be mutatable. Header needs to be mutable. Okay. Print line. So instead of print line this now, I want to derive debug. Okay, so we have our bytes. I want to get let our tree object is equal to a tree object new, and the bytes. We get that, and now we're gonna debug the tree object. So invalid digit on line 58. Let's see if that's the mode. 58. That is the mode. Okay, I think you're right. So let's store this as a string. Can I store octal as like, is there there's no octal type, right? I can't do that. I don't think it actually matters if you treat octal as decimal. You actually know if you actually know that you're doing it. Okay. Let's store it as a string though, because then we can just get the first character easily and just check to see if it's a 1 or a 4. And like, it doesn't matter if that's a number or type. We're always just looking for 1 or not 1. As far as I can tell from that documentation. Okay, let's try this. Oh, interesting. So we forgot, it starts with this null at the beginning of mode. That sucks. That also might explain why it crashed to begin with. So our null, okay, so hold on. Our mode and file name bytes, you need to be, so I plussed 1 here. Do I need a +2? No, right? Oh, wait. Well, null index, I need to do this +1. That one needs to be +1. Storing it as a decimal, if you're doing anything with it, could be bad. Like suddenly you have 8s and 9. Oh yeah, that's true. That's true. We forgot to split with the +1. Yeah, we forgot to split with the +1. I changed that here. Okay, so get the bytes from this one. Mode and file name. Okay, so I grab you. So yeah, then that should be fine, I think. There we go. So here's our mode is now, okay, 100644, which is what we had before. Okay, so we now have all the information that we need to for this. And my tea went cold. That's fun. But it's still caffeine, so it's still nice. Okay, so I have all of you. I now want to, I guess like the entire point of this is we wanted to get the file name from it because you only want the top level, right? Like given this repo here, so given this directory structure, the output expected to be is dir1, dir2, file1. We don't care about these files here. Okay. So I just want to take these file names, I want to throw them into a vector, and then I want to sort the vector by name. Okay, so we have our tree object. Let's now get the tree. Okay, so I just want the, I need to create multiple tree objects, don't I? Because we just have one. So I need to loop through our bytes. So this just gets the first one. So how many do we need? We need we have one, it's like one group here. So index next null. So it's 2 nulls and then maybe the next one from that. Yeah, I think leaving it as a string in this case is probably fine because we're not going to be doing any math on it. We're not going to be doing anything else. Like maybe we can argue that we should turn it into like a small number for memory's sake, but like these type of commands are just like run and then they quit, like the entire program exits. So it's not really going to use much memory in the end. Vacuate into vec tree object. Yeah, so I need to, can I impl on vec? I don't think I could do that, right? I can't do like a from. That'd be pretty cool. What happens after this? So we get you, is there another null at the end of here? I don't see that, does it? So we have that. I'm worried about what happens after this, right? Serde might help. Oh, Serde, I hadn't thought about that. Do we have Serde? they give us? We have request, bytes, Tokyo, clap, flate, SHA-1, hex, anyhow, and this error. Oh, they gave us error handling with anyhow. They did not give us don't edit this. No, we don't get, I don't get Serde. And apparently I'm not allowed to edit that. Can I add stuff? It just takes a bit longer. Okay, let's try it. Okay, it takes a little bit longer when we push for the first time because it has to build the new stuff. So let's buffer close you. Let's cargo add Serde with derive. Oh, Mikey, watch him get banned or something. That would be hilarious if like they partner with me. I then add one like Serde thing, and you're like, you're banned forever. Get out of here. Bye. And then yeah, that'd be hilarious. Oh, don't change the versions. Okay. That kind of makes sense. I was wondering if I can add my own error handling, like if I could use error instead of anyhow, even though there's like no difference in how I would use it. It's probably fixed in the builder tester. I wonder if they have their own satellite server essentially. That would also make sense. But okay, so we have Serde. So I want to serialize, deserialize. Okay, so we have you now. I wanted to, I wonder if that would work because I don't think it knows how to do this. I'm gonna probably need to implement serialize manually, I bet. Oh yeah, that's a good idea, Corbob. Like they, most of them just let OpenSSL handle it. I wonder we'd have to like wrap around and use an OpenSSL library to like open up the connection, and then you can do the rest of the stuff. So depending upon how GitHub works, but like if we just use like something that's not GitHub, that would also probably be easier because GitHub probably does fun stuff, or they might do fun stuff. Okay, so we have tree object from this, but what if I wanted to do like let tree objects, which is going to be a vec of tree object equals oh, this has been forever since I've done this. I wanted to serialize, I usually just use JSON. I rarely do my own. What is it? It's like Serde, it's not into, it's we've taken bytes. I think, oh, serialized, deserialize. Do I do tree object? Oh, it's probably not tree object from, it's right. It would probably be like a, oh, yeah, how would I do this? It's not gonna know to do all this stuff. I'm probably gonna have to implement my own deserializer for it. That's the only thing I can think of for something like this, is like implement deserialize for tree object. Yeah, you have to create your own tree object deserializer and implement deserializer for it. Okay, that's what I was thinking. That's what I was like, kind of like, how else would this work? I don't, it's been forever since I've done this. Let's go just take a look at Serde. We were doing game dev back when I did this last time, and I did it for like creating colors from a string, I think. Serde, Rust, you have a book, don't you? So custom deserialize. Okay, so here's this trait. You think derive would have generated deserializer for you, but how would it work? So the problem is, like, how does it know what this object type is? It doesn't know what that is. I would need to, like, I don't think there's any way for it to like know coming from even just like a slice that has this in there. It doesn't know that that's what's going to come in as. Use an enum. How would an enum help with that? Because like the name of it, because like basically, okay, we're coming in with a bytes, right? So we're coming with bytes. The bytes is just one long thing, so it doesn't know that that's going to be a vector. There's a bunch of null. There's a bunch of nulls in it. We have size for this. Yeah, so I guess I don't also like, I can't visualize what an enum would do for me either. So I don't know what how that would help. Maybe a tuple. If object type is an enum, Serde could probably parse the bytes into the appropriate variant. Okay, so if we were to say that we have like tree, right now this is the only option, right? We have tree. Let's, even though it's going to yell at me, let's put this lowercase. Deserialize. Sure, we'll just throw in serialize too. Why not? And then we say, okay, object type is now going to be object type. I have to get rid of my new now because all of this breaks. That's okay if this just works. We have the size, we have the mode, and we have the file name, but I don't know how it's going to find those because like they don't have consistent names. But again, like, so I don't know how does it know, like, okay, maybe like space based for something like this. What about mode? How does it know about that? How does it know like the difference between mode and file name? Yeah, I don't see any way of this like working, unfortunately. It's a good idea though. If it was JSON, this would work great. I think that if it was a U30, if it was bytes that are going into JSON, this would be great. Let's just make this back to a string again. That way this stuff all still works. Okay, so I think we would need to implement our own deserializer if we want to do this, or we have to just implement a loop, which like I think it's going to be easier for us to just implement. What did I do here? I broke this. When did I break that? Oh, I broke this as part of Serde. Okay, I think this is happy. Yeah, and that's the thing is like there's no key value pairs. It's not CSV. That would be the other thing that we can do. Like there's no titles or headers for anything. It is 8:30, which gives me the ability to run off and just say like, hey, yeah, I totally know what I'm doing, and we'll get there. So let's figure out what we need to do next. So we have a single tree object here, right? We're not doing anything with it, but we have it. Yeah, custom deserialization code. It can look a little bit crazy. It's not that bad though. Like if you do it once, it's okay. It's just a lot of boilerplate and a lot of other stuff to sort of work with, and then it's okay. It just is a lot. So we need to loop. So we need to figure out how long each sort of section is. So we need to figure out where one object begins and ends, and then loop through everything. So what I might want to do is like, okay, from tree object here, I could potentially we can return self and the index that we last used for the null. Then we can use that to generate the next object. Lots of question marks because that is unknown whether or not that's going to work. 200 lines in 3 minutes. Go. Yeah, that's yeah. We're not going to do that right now. But okay, I think this will work, right? So I'll probably do something like have a loop. I don't know if it'll be an infinite loop or not. Like we'll have a loop of some kind, and then in the loop here, we're going to basically create tree objects. We don't have an iterator for this. Like we could also just create a custom iterator for the bytes, but I don't necessarily know if that's worthwhile either, because this is like a one-off thing. We're only doing this once. So if we figure out where the end of one of these are, then we can consistently loop through it and basically say, okay, create a tree object. Okay, now we have the next section. Now create a tree object from that one. So we need to figure out how to get each section, and then we can loop through that. So we have tons of warnings in here, but this is fine. We're gonna go ahead and print this up. It's gonna yell at us because we don't actually have any output for this, but that's okay. We have warnings. It'll be fine. Also, we're not using Serde, so I can go ahead and can I remove? Yeah, okay, so we remove Serde from dependencies. That's great. Let's also remove our tester. I probably don't remember updating cargo lock, but that's probably fine. So git commit, let's actually run this. Cargo run. I removed Serde, so that should have re-updated everything. So let's do a git commit. Object type, a string, looks hella cursed. What's up with that? The object type is a string, so it's the word. Here, we can actually see it in this Stack Overflow thing. So it's a word like tree or blob or something like that. So I'm storing it as a tree, as like a type. Now, like if we were doing this for real, I probably would do that as an enum, but we're not there yet. Yeah, it gets interesting. Okay, so git commit am. So let's do I guess like this is a work in progress. So we're able to extract first object in the tree. Still need to extract all objects. All right, let's push this up. So if you're new to Codecrafters, if you're looking at this is what they do. Basically, you push up to their custom Git. They then build everything. So looks like we changed stuff. So they have to rebuild and recompile things. But then they run their tests against our stuff, which is pretty cool. And they give us pretty instant feedback. And let us know how things are going. So we've gone through several different challenges so far for building our own Git. And we're currently on the read a tree object. And so it will show us probably the first like 4 or 5 tests passing and then a failing test. So this entire system is really cool. If you liking what you've seen and you want to see, they have all these other challenges too that you can do in lots of different languages as well. If you like all this stuff, free account only lets you try the first few steps. Yeah. So I think also build your own DNS is free during beta. So I think you can get access to the build your own DNS server. Then the rest of them, you would need a paid account for it. It's on a subscription service, so it's like 3 months, 1 year, lifetime. If you're interested in purchasing this, I have a link in the YouTube description